In this video, we're going to begin looking at scientific notation. Scientific notation is a way of writing really big numbers or really small numbers in a very compact and precise way. So in science, a lot of times you will see that something might be 3.6 times 10 to the 12th power away, like say in outer space. This would be a fancy way of writing. If I take 3.6, I would need to move this decimal place over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fill in the zeros. Okay. If I put the commas in, this would be how far away something was. But instead of having to write all the zeros out, this is a little bit more concise way of writing it. Because once again, this would mean 3.6 times 10 to the 12th, which if I add 12 zeros, 3, 4, 5, 6, 7, 8, 9, 10. It's a more precise way of writing it. Okay. We also could write numbers that are very small, in this case 3.6 times 10 to the negative 12th. The only difference is this negative sign here. What that means is I'm going to take the 3.6 and I'm going to multiply it by actually 1 over, and it's going to be the same number with the 12 zeros. Which actually means I'm actually going to take 3.6 divided by it. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This small of number. So instead of writing out things with all the zeros, it gives us a sense of the number without writing it. So how is scientific notation set up? Okay. Basically, it will always be start off with a number. This number needs to be between 1 and 10. So basically it could be 1 point something all the way up to 9.9 repeating. Okay, so it can't hit 10 and it's got to have at least the 1 in front of a decimal place. It's always going to be times 10 raised to some value. And what this value is becomes very important. If this is a positive value, means we're dealing with a very large value. In other words, it's going to be greater than 0. If this value is negative, we're going to be dealing with a small value. In other words, something less than 0. And what the number itself tells us is how many spaces to move the decimal. Okay. And what I would like to do before I go much further is just correct. When I talk about being a positive, being a large number, we're talking about being greater than 1. Okay? When I talk about negative, being a small number, we're talking about being less than 1. Those are supposed to be 1s and not 0s. My apologies. Now let's move on and let's take a look at some actual situations. If we are given 36,000, okay, first thing to do is to find the decimal place is actually here. For scientific notation, I need a number between 1 and 10. So in order to have that number between 1 and 10, we know that it needs to be 3.6. And we know that it has to be times 10. The question is, what will go for the exponent? So the first thing to figure out is how many spaces do we need to move the decimal? So I'm going to move it 1 space, 2 spaces, 3 spaces, 4 spaces. So since I moved the decimal 4 spaces, it'll be times 10 to the 4th. Once I get the number, the numerical value, my job is to figure out, is this number going to be positive? Is it going to be negative? Well, if I'm dealing with 36,000, I'm dealing with a large value. I'm dealing with a value greater than 0, so I know that this exponent will need to be positive. Let's do another example. Okay, let's take one with a negative exponent value. If I give you something like 0.000482, okay, first thing to consider is where does this decimal need to end up to get a number between 1 and 10? Answer would be 4.82. Then I know it's times 10. My question is on the exponent. I have to move the decimal spot 1, 2, 3, 4 spaces. It's the same as above, okay? But in this case, if I'm dealing with 0.000482, I'm dealing with a value that's smaller than 1. Actually, I'm going to change that before to be less than 1 and greater than 1. Okay? In this case, since I'm dealing with a value less than 1, it's going to end up being a negative value. Okay? So that's where my answer will end up needing to be. Okay? So it's going to be 4.8 times 10 to the negative 4th. Going in the, if I give you something like, I don't know, 2.1 times 10 to the negative 5th power. Okay. First of all, I start with the 2.1. I look at the negative sign. I know I need a decimal value because it has to be something less than 1. It has to be a very, very small value. So in order to get that small value, I'm going to move the decimal place to the left to make the number smaller. Since the number is 5, I need to do 5 loops. And I'll put my decimal here. I then fill in the zeros, fill in the loops with zeros, so my answer will end up being 0.1234421. Okay? So it's doing the same thing in reverse. If I had 4.6 times 10 to the 3rd power, I'm going to start with the 4.6. Since I look at the to the raised to the positive 3, I'm dealing with a number that's going to be larger, in a sense larger than 1. So I'm going to move the decimal place to the right. I need 3 loops. Fill in the zeros, and I'm going to get it equaling 4,600. And that's scientific notation.